All right, let's take a look at this lesson. We're going to be looking at geometric sequences and series. So let's kind of review what we've done so far just to get a feel for what's going on. So the first lesson we learned about sequences and series. You know, what's the difference between a sequence and series? Really important. I'll ask you about this again. A sequence is a list of terms, and a series is adding the terms. And that's what sequences and series are. We learned that there were arithmetic and geometric sequences, and also neither. So we have three categories to put them in. We looked at arithmetic sequences and series, how that works with the common difference and the two different ways you can find the common difference. So we're going to expand our understanding, and we're going to work on geometric sequences and series. So on this side, right here, these are on my left side, we're going to talk about the sequence formula. And on the right side, we're going to talk about the series formula. Okay, so let's start out with the sequence formula. And let's talk about what all the parts mean. So a sub 1 means my first term. That's what that means. R is my ratio. These ends, both of those ends, mean term number. Okay, that's the term number. And so this is the formula to generate any term you want in a sequence. Let's see, you wanted the 100th term. You would just put in 100 for n, and then you're good to go. You'd find out what the 100th term is. Our common ratio is this formula right up here. It's a little trickier than the arithmetic formula because you've got to have the next term over the previous term. Unlike arithmetic, when we were able to find the common difference in just a kind of a cool way right here, if we're separated, you know, the 8th term and the 12th term, we can still find the common difference by this little formula. With geometric, we can't. We have to have the numbers together like that in sequence. And if they're not, what we have to do is we have to do some kind of a formula, or maybe solve a system. It's a little bit more complicated. Okay? So now let's look at series, the formula for series. Let's talk about first of all, let's talk about this strange little symbol right here. You may or may not have seen that before, but that is the Greek letter sigma. And for math, what that means is sum. You're going to add stuff together. Now, we're really not going to do much work with this type of notation in this course. You will get that in pre-cal. So instead, for this part right here, we're just going to call that S sub n equals, you know, that stuff right there. So we're just going to replace that more formal notation with an S sub n. And S sub n is our partial sum. That's a really important concept. So if it were S sub 6, that would be our 6th partial sum, which means that you add the first 6 terms. I mean, that's what a partial sum means. You're just going to add, you know, the first 6 terms, or maybe you want to add the first 15 terms. It's just really whatever you're asked to do or whatever you want to do. Okay? So the parts of this formula, a sub 1 is, again, it's our first term. R, both of these R's are the same scenario. That's a ratio. And this is the number of terms, as is this n. That is the number of terms. If you notice, the two formulas, the sequence formula and the series formula, both have n's in them. It's important to note that in the context of the formula, in the context of the sequence formula, the n is the term number. But in the context of this series formula, the n is the number of terms we're adding up, because it's an adding formula. We're going to add all these things up. All right, so that's our formulas. Let's go ahead and go down to our problems. You will need a calculator for this lesson, so hopefully you have your calculator handy. On this first side, the left side, we're going to talk about the nth term, which is basically the sequence formula. The sequence formula was the first term, and we can put that in parentheses, times r to the n minus 1. Okay, that's our sequence formula. This is the one that we're going to be referring to when we are finding nth term. Okay, so our first example asks us to write an equation for the nth term of each geometric sequence. So basically we are just going to be substituting into this equation. That's what they want us to do. So we need to find a sub 1 and r. So this first term is a sub 1. R we get, the formula is by taking, the next term. We're going to use 8 as the next term over the previous term. Why did I pick that? Well, because that seemed easier than using the second term, which is 2, divided by the first term, which is a half, which would be 2 times 2 or 4. So it doesn't really matter which consecutive terms you use, as long as you do the next one over the previous one. Okay, so now we have our r, so we can go ahead and plug into our formula. So a sub n is going to be a sub 1, which is 0.5, times r, which is 4, raised to the n minus 1. Now I hope at this point in our math career, I don't have to say this, but I'm still going to say it. I'm going to put a little asterisk, I'm going to put it in pink. Very important. You cannot multiply these numbers in this form. Cannot. Okay, let's put a y down here. Why? Why can't you multiply those two numbers together? Why can't I say a half times 4? The reason is order of operations. In order of operations, we are required to do the exponent before the multiplying. And since we don't even know what n is, there's no way we can do the exponent first. So because of order of operations, we have to do exponents before multiplying. So many rules in algebra, aren't there? Lots of rules. Got to remember a lot of stuff. Okay, so that's why we can't do that. So please don't do that. Okay? So this is our answer. This is our nth term. That's what they wanted us to find, was our nth term. We're done. On part B, they're asking the same thing. They want us to do the nth term. But notice how I have the r right here, but that's not the first term. That's a little bit of a problem. Let's see how we can figure out what to do. So my r is a 6. Okay, got that. And I don't know my first term. And I've got, I'm just going to copy the formula down, right? So let's see. So what have we not used yet? We haven't used this. Let's try to figure out how that could help us. What could we do with that so that we could figure out what a sub 1 is? Why don't we put the 5 right here as the fifth term, a sub 1 to the 6 to the 5 minus 1. Why don't we do that? That seems very helpful. That would be very helpful to us. Okay, so I don't really want to do 6 to the 4th like in my head. So this lesson I mentioned at the beginning requires a calculator. So if you would, let's go to our calculator. And let's put in 6 to the 4th. So let's add our calculator. And let's type in 6 raised to the 4th power, because we don't want to do that in our head. That's, oops, no, 1296. Let's go back here real quick. Okay, so we want, oops, that is the 4th power. I'm so silly. So it should be not 5 minus 1, it should be 4 minus 1. So we really should be doing 6 to the third power. Okay, so let's fix that. So we want to do 6 raised to the third power, 216. Okay, great. So let's go back here. So that number is 216. Then I have my a sub 1 right here equals 5. So a sub 1 is simply going to be 5 divided by 216. I know that's a weird number. We can't really reduce it because 216 doesn't have a factor of 5 in it. So let's write out we're ready to write out our formula. So a sub n is 5 over 216, 6 to the n minus 1. Okay, great. All right, so let's take a look at one more. Let's get the idea about one more. Let's see, do we have our first term? Yep, that's our first term. Can we figure our common ratio? Yes, I'm going to choose negative 16 divided by 2. Seems easier than the other one. Again, it doesn't matter. Since they've told us these are geometric, then you can pick any two consecutive terms to find r. So r is going to be negative 8. Oh, this is nice. So we just get to write the formula. So a sub n equals a sub 1, which is negative 0.25, times r, which is negative 8, raised to the n minus 1. Okay, great. So that's our work on sequences. Now let's start working on series. Let's go over here and work on some series. Let's first of all write the series formulas up here. Let's just get them ready. So S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. And a sub n equals a sub 1 times r to the n minus 1. Okay, and you can put a sub 1 and r in parentheses if you want. That's fine to help, separate them out. Find the indicated sum. Okay, we have the first term. We have the number of terms we want. So S sub 10, which means I'm adding up 10 terms, equals a sub 1 is 2 times 1 minus r is 3, and I have 10 terms raised to the 10th over 1 minus 3. Okay, great. So what we're going to do is we're going to go to the calculator and we're going to input that in the calculator. And the calculator that we use is very particular. So let's make sure that we put everything where it's supposed to. So we have to do 10, then you have to do a times here. You've got to do a times between the number and the parentheses. It doesn't really like it when you don't, so please do. I need a fraction inside there, so I'm going to go to our fraction bars and put that in there. Great. So I need a 1 minus. Now this next is a 3, and I need to raise that to the 10th power. So I like to use this little caret thing to raise that to the 10th power. Okay, great. Then in the denominator, I'm going to have 1 minus 3. All right, wonderful. So we hit enter and we get 59,048. All right, so let's go back here and enter that. So this sum is going to be 59,048. So S sub 10 is 59,048. Great, not that bad, right? Okay, so let's see our next one. We have the first term, but then what do we not have? What are we missing here? Let's look over at the formula. What are we missing? Let's see, we're missing an n. How are we going to find an n? Well, they give us an a sub n, which is like, do you recognize that? A sub n, that's like our sequence formula. Okay, all right, let's use our sequence formula. A sub n, so we're going to use this one right here, is 125 equals a sub 1, they gave us that, 2,000, And then r, oh, they gave us r, 1/2 to the n minus 1. And we don't know what n is. All right, so what we need to do is figure out how to solve that. First thing I would do is 125 divided by 2,000. Well, let's go to our calculator. So 125 divided by 2,000. 1/16. Okay, so let's go back over here. So that's 1/16 equals 1/2 to the n minus 1. Let's think about that. So we did this a few units ago when we did exponentials. Remember that? Where we'd have, remember the technique we used to solve that? Yeah, we have to make the bases the same. So I have a 1/16 and the 1/2. And we always, so the 1's match, but the 16 and the 2 don't. So instead of messing with the 2, I need to mess with the 16, right? We mess with the bigger number. And how can I turn 16 into a version of 2? Let's see, 2 times 2 is 4, 4 times 2 is 8, 2 is 6. So it's fourth. So I basically could write this as 1/2 to the 4th power equals 1/2 to the n minus 1. All right, so what did we do? And we got the bases the same. Yeah, we ignored them. We just ignored them. They don't cancel or anything. We just ignore them, and we set the exponents equal to each other. So we see that n is 5. Okay, great. Now we have all the information we need to find our sum. So we need our 5th sum. So s sub 5 is, that's our 5th sum, is going to be our first term, which is 2,000 times 1 minus 1/2 raised to the 5th power over 1 minus 1/2. Okay, so this is a little bit more challenging to put in our calculator, but we can do this. So let's go to our calculator. So we need to put 2,000 times, so let's open a parenthesis, and we need a fraction. All right, we need to do 1 minus, now this is a fraction that's going to be raised to a power, so really it would be better if we put a parenthesis, then another fraction, so it's 1 minus 1/2, and I want to get right outside these parentheses, right between them, and do this caret, so it's 1/2 to the, what do we say, 5th power over 1 minus 1/2. Okay, looking good. So let's hit enter. And our sum is 3,875. Great. So let's go back here. So our sum, so s sub 5 is 3,875. Okay, great. Last one. Find A1 in a geometric series for which, oh, now look what they're giving us. They're giving us S sub n. So that's definitely the series formula, not the sequence formula. So S sub n, 13,116, equals A sub 1, that's what we don't know, times 1 minus r raised to the n power, which is 7, over 1 minus r. Okay, so we're really focusing on, we want to find out what this is. So let's see. Why don't we put that weird 1 minus 3 to the 7 over 1 minus 3, why don't we put that in our calculator and just turn it into a regular number? Then it'll be better to, to figure out what in the world's going on. So we need to get to a fraction. So we've got 1 minus 3 to the 7 over 1 minus 3. Okay, 1,093. So let's go back here. Okay, so solving for a sub 1, I would simply divide these. And it turns out to be, excuse me, 12. And of course I did that in my calculator, not in my head. All right.